All right. So I'll get started. I want to first thank you personally and on behalf of the ASHRAE BIM Steering Committee for having me present to CIBSE this evening. My goal tonight is to kind of talk about building information modeling, go through, and I'm going to talk to you about it from a small to mid-size architectural engineering firm that has spent about 6 years now learning the BIM authoring tools, integrating it into our practice, and slowly bringing our consultants on board, and now seeing more and more involvement on the contractor side, as David mentioned earlier. So with that, I'll get started. Let's see. I think I actually started with the last slide instead of the first. Okay. So some of the learning objectives this evening is to define BIM, and I'm going to use an industry standard definition here in a few minutes, talk about some of the values that we have seen in our practice with BIM, and then some, maybe some of it you may consider flim-flam, a little bit of pie in the sky, but not much. Most of what I'm going to talk about is things that we're doing, or architecture contractors around at least the southeastern United States are able to do right now. Give you a couple of resources if you're just in the early stages of talking about adopting BIM that you might want to use, and then some of the things that we're using BIM for that may create new opportunities, new markets for architects, consulting engineers, contractors, detailers. To start out with, during the ASHRAE BIM Steering Committee, we talked about a lot of definitions, and the one I think we finally settled on and put into the ASHRAE Guide was the one from the National BIM Standard, the Building Smart Alliance. It's the most succinct and concise, and basically what it says is that a BIM is a digital representation of both the physical and functional characteristics of a facility. That being the case, the BIM is to be a shared knowledge resource about the facility, forming a reliable basis for decision making throughout the life cycle of a facility or building. And that's defined as existing from its earliest conception right through demolition, or in the case of sustainability and the way buildings should be built, through their adaptive reuse. Next step in that we're working within ASHRAE is creating a data dictionary that translates a lot of our standards and a lot of the energy codes and indoor air quality and ventilation standards into a digital, readable language that can be understood and interpreted between, say, a physical model and an analytical model that we'll talk about a little bit more as we move into the presentation. Now, why do we need this? We all know these statistics pretty well now, that buildings consume about 40% of the energy and 70% of the electricity that's generated, at least here in the United States, and that we're running out of our natural, non-renewable fuel bases. And we have poor indoor air quality, rising healthcare costs. So it's at least my belief that the HVAC industry is poised to help solve a lot of those problems by improving the efficiency of buildings, the indoor air quality in buildings, and that in turn opens up tremendous opportunities for our young engineers and those entering the fields today. I think we have a good future in this business, and I tend to be a glass half full person anyway. Add to those statistics that 70% energy, about 50% of it is consumed by the air conditioning systems. So whether you're the owner, the engineer, or the contractor, optimizing those HVAC systems and keeping them working at optimum capacity and optimum efficiency is going to become more and more important from a health, safety, security, and indoor environmental standpoint, and just from a cost standpoint. Again, as fuel prices begin to soar and cost us more money, the onus on keeping HVAC systems working the way they were intended will become more and more important. So, where are we at? About 6 years ago, our firm decided that we were going to move away from this two-dimensional project delivery process. And so we were at a crossroads of going from two-dimensional delivery to a three-dimensional working environment. We're still delivering two-dimensional black and white drawings to contractors for bidding purposes, for contractual obligations and those things. We are not at the point of delivering that 3D model to a contractor, at least on most of the work that we work on. But we do 100% of our work within the office now in this 3D environment. We only have one or two federal agency clients that still require a 2D electronic deliverable. So we actually work in 3D throughout the design process and then convert those documents to 2D for delivery at the end. All right. So to do that and move into a 3D virtual work environment, we need tools that are capable of analyzing a building under almost any expected or unexpected condition. Not be it from a analytical basis from energy or daylighting to a security breach to just a natural disaster. To optimize our buildings and continually get more out of a building for less money, we've got to have some integrated and interoperable tools. And I think that's where building information modeling will be the essential tool that will ensure that we're able to do that and meet those challenges head on. In fact, some of you have probably heard Gordon Holness, our past president, say that he believes that BIM will not only change the way we design and construct and operate our buildings, but that it is going to change the very way we work, live, and interact with our buildings. And I believe that as well. I mean, with our smartphones and smart technology and tablet PCs and integrated security systems, that the future of BIM is, we're just now scratching the surface. One thing I do want to mention, though, and we've actually learned that here in our office, is that BIM is a tool, and it's a tool that you need to apply just like any other tool. It's not 3D CAD. The objects within the system are smart, and that's, if you're going to adopt BIM, that's the intelligence of BIM that you want to capitalize on to create efficiencies. The other thing is it's not going to fix a silo thinking process. If you are not in the mode of working in an integrated fashion and bringing your consultants in early, and right now starting to see more and more design build in the area, getting the contractors on board very early and working within these systems, either with their own BIM systems or working with the designers within BIM to do very early coordination. It's just not a substitute for that good management practice. BIM by itself is not going to fix any of those fragmentation or non-integrated project delivery or lean construction practices at all. So many of you have probably seen this curve. It's more got to do with an integrated project delivery process than necessarily BIM. Again, applying BIM as a tool and capturing that data can eliminate a lot of the things you saw on that last slide. But essentially, for anyone who hasn't seen this graphic, I think it sums up the construction business pretty well in one slide. The green line represents our ability to impact cost of a project from design throughout construction and operation, and pretty much from the standpoint of making those early decisions, the green line you can see, our ability to impact that cost diminishes as we move further and further out on the project timeline. This red line here is the cost of changes, and of course the further we get to where we get here into construction and we're not working within our virtual environments or on paper and begin putting up bricks and mortar, the more and more expensive changes become. Our traditional methods of actually designing and constructing have, for the most part, followed this third line, the white line here, where we do a little bit of design, get a sign-off by an owner, get further into the design with more and more details. Right here, find out the project's over budget as soon as it's bid in almost 100% of the cases under a traditional method. We value engineer the job and go from there. The key to an integrated design process and capture of data that everyone in the process can use early on is trying to follow this blue curve here, where our decision-making processes that might impact the cost and coordinate the project happens well before we ever bid this job and move way out here on the red line. So, who's going to drive this train? I think I looked through some of the earlier CIBSE programs that's been on BIM, and I saw some discussions about the government making some mandates and things like that. What we're seeing here is a combination of architects and owners driving the adoption of BIM a little faster than, say, a consulting engineer or design engineer. A lot of the larger, our healthcare clients that do larger hospitals are beginning to request that we do it in BIM and do our coordination. And in most cases, there's a contractor brought on board early there too. Surprisingly, we've got a good many contractors and subcontractors who are adopting BIM faster than, say, the mechanical and electrical consultants that design the systems. We have a contractor up just a couple hundred miles north of here, Rogers, that does not do any of their work that's not coordinated through BIM anymore. Even if they receive 2D documents from an AE, they in-house have architects and mechanical, electrical, and plumbing engineers that then recreate all that work into a BIM and do their coordination and planning before they ever begin construction. One of the biggest things we saw early on, because when we adopted a BIM authoring tool about 6 years ago, we didn't have any consultants that were using it and no contractors. But we did see a marked improvement even in that first year of adopting the tool in our productivity, and I would estimate, based on looking at our numbers, that we picked up about 15% better production purely through better visualization and being able to understand the building better. Now that has diminished some now, because as we have become better at visualizing and better at making decisions sooner, I think some of our designers tend to play with the job a little bit longer. So I've begun seeing utilization or chargeability rates drop a little over that 6-year period, and I think it's because it does allow us to tend to work on the job a little bit longer and consider more options than we used to. The other thing is that the clients and community that we've been able to take our projects to, some of the biggest compliments we've got from school boards and county councils and some of our municipal work and those kind of things, is that they understand the building, and the building ends up looking the way we showed them. So quite often people in the non-construction trades have a very difficult time visualizing what a building might look like from a two-dimensional perspective. Here in Charleston, we have a very strong historic preservation organization. We have over 3,000 historic buildings in Charleston, and so our boards of architectural review tend to require physical models of most anything that's going to be built. Using BIM and our BIM authoring tools, they have begun to allow us to substitute some 3D renderings that they normally would not accept if they were hand-generated renderings versus the way we're able to show multiple views of a building in 3 dimensions. Now, one of the biggest things that I think BIM offers us right now is the ability to do better coordination. And that, again, requires an integrated process with almost all of the team involved in the BIM. So many of our areas are ultimately exposed during the construction phase, and that's a costly phase. Again, if you remember the red curve on the McLean graphic. And then others can go for years without being detected or becoming apparent. And if any of you still do, like I do a lot of the quality control in the office, the manual phase of coordination, like on the left, flipping back and forth between multiple disciplines is still a difficult way to check a set of drawings, and even after that's done, I think I've seen a statistic where we still have somewhere between 3 to 5 errors and omissions on every sheet, even after it's been well coordinated manually. A lot of that can be solved purely through some interference checking within a BIM, again, as long as you've got the whole team on board. Something that's starting to take hold and in a pilot phase is some enhanced ability to demonstrate code compliance. Again, Charlotte, North Carolina has been piloting a project to do an automated code compliance check for the International Energy Conservation Code, where you can upload a BIM to the building official's website, run a model code checker, and receive a report on your building code, your energy code compliance. From what I understand, the state of Wisconsin is also piloting that same program that comes out of the International Code Council. Another good advantage to a BIM, and I think a member of CIBSE told me this, that you all had commissioned a study back at one of last summer's ASHRAE meeting, that we tend to transfer data between ourselves during design and construction 7 times, and usually all 7 of those times is in some different shape or form or format. By having the data inside this BIM, we're able to make some better budgeting and purchase management decisions, and quantity takeoffs are quite accurate and very doable at this stage of BIM development. A lot of the BIM authoring tools, all of them have the ability to extract quantities, and a good many of the cost estimating programs are able to take those quantities and plug those into a budget or cost estimate. Same goes for schedules. Schedules can be more accurate as the objects within a BIM are assigned either successor or predecessor activities. And again, just like the takeoffs, when the takeoffs are more accurate and more well-defined, you have the ability to take a lot of the guesswork out of what has to be done to build that building. So some fairly simple tools that are available to kind of help build a building or virtually construct it without having to go out and actually put the shovels in the ground and start moving earth is through 4D simulation. Most of that can be done through integrated or third-party software that allows that schedule that was just created to sequence the objects within a building as to how you might build it. So in that case, what you're able to do is anticipate some problems that may occur. I'm going to step through several slides to show what a 4D simulation might look like, tying the objects within a BIM to the objects in a schedule, the objects in a construction schedule. So here might be day 13 of week 2, and then we move on through day 32, day 40, day 74. And of course, these are probably unrealistic days, but just some days assigned to a schedule to do this simulation. And then finally, say on day 96, the building's finished out. What that allows a contractor and a design team to do is see how each component of the building might go together and see where you might have staging problems. You can stage your cranes, your scaffolding, your temporary facilities on the job site, and that, along with the actual construction, anticipate where you might have a bottleneck. This does a couple of things. One, it allows you to see how the building might go together and maybe give you opportunities to put it together in a more efficient manner, but it also allows you to anticipate how the site might be used and to keep that site a little more clean and a safer and cleaner site by virtue of doing that. Something that's turned into quite a market for several of our structural consultants, and beginning one of our focuses in the whole building systems side of this is to work with contractors on automating fabrication, going straight from BIM into a fabrication shop for things like steel, ductwork, and pipe. One particular structural engineer locally has brought on 3 steel detailers and pretty much is doing most of the BIM tube fabrication work on a lot of the projects they do, and it's turned into a very nice new market for them. Same with the manufacturing technologies. By doing that, by working and coordinating schedules with your fabrication needs and your delivery needs, you get to a way of basically lean construction processes, just like lean manufacturing processes. Again, it speeds the construction up. It gets rid of clutter on the site, the need for so many storage containers, and keeps the site safer as a result. Finally, one of the things that we're working with a local college client right now is trying to integrate their as-built, their record documentation, and those kind of things into the BIM that we created for them when we did their job. So to eliminate some of these paper-based record documents and link them to objects within the building. So what we've done in this case is we've created an electronic systems manual, if you will, where things like operations and maintenance manuals, warranties, test and balance reports. Those things have been created in a PDF file, some of them in a spreadsheet, and then those have been linked to the object in the BIM, and then a simple reader has been given to the owner so that he can view the BIM and right-click on a piece of equipment and then click to a link that would get into a spreadsheet or a PDF document. And then that's been set up on the university's server, and we're learning as we go, but it seems to get better on each project how we're able to tie those things together for them. And then we found, too, that on our commercial clients where you wouldn't think, well, it's not advantageous to use BIM in, say, a strip shopping center or a speculative office building, but it's been a whole lot better to work where we've got a BIM and we're doing a tenant upfit or somebody moves out and somebody else moves in. It's been easier, and we're more confident that our record drawings are as-built and tend to spend a little less field work time verifying those things when we go out to do a new job within an existing building that we've worked on in the past. This one's probably a little bit of a pie in the sky. I know it's being applied up at the renovations that were done at the Pentagon, but some of their BIM technologies were linked with their security and their disaster recovery assistance to use the RFID tags and the access control tags to be able to locate people within the building, and that would be a tremendous help during a disaster or something like that. To if someone was in distress and could signal it, and then a BIM could be called up to find out exactly where they are within the system. That work is ongoing. Same with as we move to optimize our buildings a little more, it becomes much more important that we're able to do performance-based design. And by having that kind of data and using our analytical models to design buildings, should be able to economize on some of the materials and find multiple uses for systems within a building, so that the system sizes and the number of components within a building can be cut down. And that's probably a more optimistic and futuristic look at where we might go with them. Same with whole building optimization. We are working to, we do not use an integrated energy management or energy modeling system within our office. It's a third-party piece of software, and it's been a slow process, but we're getting there, and I'll step through a case study in just a second as to how we're working toward being able to export data and run our loads for energy modeling and equipment sizing. So I'll just go through the case study fairly quickly. Define, and we'll talk about a BIM and a building performance analysis and understand the difference between what might be called a physical model and an analytical model. We'll talk about a couple of the data exchange methods between the two that has to happen in order for you to take advantage of the data that's been captured within that physical model. And then some of the things that are kind of critical if you're going to export data to try to run at least HVAC loads, to have an architect or someone that's generating the architectural design to pay attention to. So a physical model is just what we've been talking about, and that's just the geometry. For for most part. What's able to be used for interference checking, for visualization, and for demonstrating to a client, say, a tenant upfit or something like that. So what has to happen in a physical model to prepare it to be used effectively in an analytical model is those objects that are in this physical model have to have data associated with them that are useful. In our case, solar heat gain coefficients, U values, R values, densities, weights, mass, and those kind of things. So to really take advantage of the power of BIM, you have to get into the habit and build into your work process and your office standards the kind of data that you're going to include in that BIM document as data attached to each object. Once that's done, in this case, we use a third-party modeling software. You export the data into the software, and it takes a fair amount of cleanup. It's not just a straight read and run, and it's not parametric at this point. I cannot make changes in the model after I've run this energy analysis and then a quick export and run it again. It takes basically the same cleanup process each time you want to change it. So it's a little bit of work. The takeoff square footages and areas are the biggest advantage to speeding up the process there. How most of the interoperable and integrated systems work are they use two different more common data exchange formats. One's called IFCs, or International Foundation Classes, or GBXML, or Green Building XML. And essentially these are, when they're exported like text files where you tag the start and stop of a piece of data that might be useful like the room name, and what gets exported as the room name is what's between the two tags. So in our process, and I won't say it's the best process of how we adopted BIM, we just pulled the plug on CAD 6 years ago, bought 14 seats of the BIM authoring tool and jumped in with both feet. And jumped in with both feet on our first project was a 400,000 square foot high school. That proved to be challenging, but again, we did pick up some efficiencies. What I would, hindsight would probably say, is to study your needs and anticipated uses for BIM. Make sure the BIM tool, there's still a lot of opportunity with having to deliver documents in 2D, but you're going to have to do some 2D drafting. That the authoring tool has the capability to allow you to draw in 2D and insert 2D details. That can add some inefficiency to your process too if you just try to model too many things in 3D. Anticipate your client software. If you're working for a federal or a government agency, find out what kind of software and deliverables they anticipate now and in the near future. Wouldn't want to invest in the software because it's not cheap, and then find out that a client wouldn't accept the files from that software. Evaluate your hardware needs. We'll tell you that everybody told us that we probably needed to go to 64-bit machines, and we have on several machines, and those are only the machines that we do a lot of rendering on. We've actually found that our 32-bit machines for just day-to-day work effort are quite adequate for the normal work we do. It's when you try to start doing a fair amount of animation or photorealistic rendering that the 64-bit machines come in handy, and even those in some cases run overnight or over a weekend to render a building. Some of the tricks to, if you're going to be rendering or doing that photorealistic work, and you only are concerned with the outside of the building and not doing fly-throughs, is save a copy of the file. Just strip out all the geometry inside the building and render nothing but that exterior envelope to speed that process up. Look at several vendors. Give their software a try. One of the references at the back of this presentation is called a little book called Big Bim, Little Bim. It's kind of BIM on a budget by an author named Kenneth Jernigan. And he kind of suggests that if you're not able to, after 3 days, at least with some reasonable confidence, generate a project at the level that you would be proud of showing it to a client, that maybe that's not the solution for you, and that you should look at evaluating other software before making a decision to purchase. But just getting started, I do believe it's the way the industry's going. As an architectural firm, or having managed an architectural firm, to capture the full benefit, we really need consultants, contractors, and subcontractors on the platform as well. Training, we've taken a different approach. We started out by sending a few people to training and asking them to come back and train others. We've actually found it better to use the software, work out. We've created a group called the Reviteers within the office that meet every 2 weeks. Once a month, someone from the office will do training to everybody in the office, kind of rising tide raises all boats, to keep the level of expertise within the office about the same with anybody that's using it. Now, we do have a couple of people that are better and more apt at doing rendering. But the other thing we've done with our supplier is, rather than really long training sessions where you get so much information you can't really absorb and take back, is every 2 months we have them down for 2 to 4 hours, and we give them a specific list of things we're either having issues with or things we want to improve upon. And we're getting a lot better bang for our buck out of our training, and the entire office is getting much more efficient at applying the tools. Same with templates and standards. If you decide to adopt BIM, evaluate what you're doing in 2D and your old ways of doing things, and really spend some time early on setting your templates and standards up. It'll save you a lot of time and get you up to speed much faster. Schedule generation can be doors, windows, HVAC, grills, lighting, electrical panel schedules. Those kind of things can be automated within BIM rather than being hand-generated in a CAD or 2D environment. So spend some time early on getting those standards established and built into your templates. And then I mentioned the new markets. A new market that this whole building systems that I'm heading up right now, 2 of those will be in the coordination area for contractors that haven't quite adopted BIM, and the fabrication from BIM to fabrication are the 2 areas that will be focused on as far as a new market for an AE firm to enhance and improve our revenue and use the talents we're developing in-house for more than just design. Resources, ASHRAE's got a nice little introduction to BIM that's available for download for free. The Building Smart Alliance and the National BIM Standard. National BIM Standard is probably working more on interoperability standards and data dictionary information than how-to guides on how to model buildings. The GSA BIM Guide series that's available on the GSA website has some very good data on modeling, instruction, and best practices of how to set up a model, both from an architectural standpoint and an engineering standpoint. And then the vendors all have good white papers available on how to use their specific products. And then here's some references that I mentioned earlier. The ASHRAE BIM Guide, a handbook. It's 4 or 5 years old now, called the BIM Handbook by Wiley. Excellent handbook, probably a couple of hundred different software packages. It also explains the value of BIM not just to the owner, the architect, the engineer, but the contractors, subcontractors, fabricators, and operations and maintenance staff. It's a good reference book. The GSA BIM standards, National BIM Standard, and then finally the very short read is The Big BIM, Little BIM by Kenneth Jernigan that I quite enjoy reading, and it helped as we were getting started. And with that, that's the end of my presentation. I'm happy to take questions and talk about some of the experiences we've had. So Tim, you want to take it back?
As David, and thank you very much indeed, Dennis. That was a very thought-provoking presentation. Can I ask, we've got 25 people here in London. Are there any questions from the audience here while we're just checking the online questions? Right, the first one I've got is, from your experience, Dennis, do you find that you're actually you're getting closer to the design intent of the building? In other words, does the building operate closer to the design?
I think a lot of that has to do more with the commissioning processes and the owner training and the operation. I do see that we are truly having fewer RFIs or issues that get to the point of becoming RFIs and the buildings actually going together much closer to the way we intended. For example, the 400,000 square foot high school, we've actually set up in the project trailer a workstation that we can remote desktop into the office. We have issues that come up at our weekly meetings or our monthly meetings where we're actually able to remote desktop in, call up the model, go to the particular part of the building, review and talk with the contractors and subcontractors about the way we envisioned it going together, even though they were working from a 2D model, show them that it can go in the way we anticipated if they will set things here, or there. The other thing is we've taken some of these 3D cuts out of the building and just printed them 2D and put them up throughout the building, so even workers and tradespeople that may even have a language barrier from a communication standpoint with multiple languages on the job site, they can see that picture and much more quickly and see how we intended things to go in. And we're seeing that we're having fewer questions or fewer issues that get to the point of becoming RFIs.
Thank you. We've got a couple of questions on energy software. One from Richard Crampton: what third-party energy software do you use? And also from Mike Molina, who is asking for some more detail on how you can integrate BMS and building energy monitoring systems into BIM process.
Well, I know, and I'm so used to doing an ASHRAE program where we don't mention products, but so I'm assuming that's okay to mention here.
You can.
Okay. Actually, I use a train trace, and I've used train trace since it was punch cards, so it was kind of hard for me to pry it away from my hands when we started doing this. So traces, all the BIM authoring tools are able to export a GBXML file. And what I've been able to do is import that file into trace, and I will tell you that the things that I get good data from are areas and room definitions. Everything within that BIM, if you can think of the room as being the parent, and the walls, roofs, ceilings, windows, openings, the children of that room, as long as the BIM is set up from the architect where every room is defined with a room number, if you end up somehow creating a BIM where there are no room numbers, you'll get a lot of garbage when you export that GBXML and bring it into, say, trace. What trace does not handle very well, or what GBXML doesn't seem to handle, in my perspective right now, are voids. I have to correct for the space above ceilings, or if I have columns in a room, and I want to extract that area from my model or include that area, I have to go back and be very careful at checking the model for spaces like that. If your walls don't go to the deck and you don't have a good definition of that room, you'll get garbage. So it's a good quick tool to get areas and square footages out of, but you have to be careful on relying on the other data. Most of the manufacturers I know, and I'll just mention a couple, and Drew Crawley may even be on the call today, but Bentley is working on integrating some of their analytical tools into working much more closely with their BIM authoring tool. Another popular software, Autodesk's Revit and their Ecotech and Green Building Studio. Green Building Studio seems to have to be run very early when you basically got more just height, scale, and mass. It bogs down when you start adding a lot of detail to the building, and then their Ecotech software is more their design software that works, again, with a GBXML file.
Okay, and we've got
answer the question?
Yes, you did. Thank you. Another question. Full of a room full of consultant engineers here, and so they've got down to the money. So, a question of really, do you find that offering a BIM puts an increase on fees, and also, in your experience, are the clients prepared to pay the additional fees? And that question is from Phil Todd.
Okay. Well, Phil, I think it's about like everything else. Most of the clients don't want to pay a lot more money for anything. They assume if we're using a newer technology that we ought to be able to do it faster, quicker, and cheaper. Not been able to really charge a premium for BIM in the work that we do. Where we have picked up a little more revenue for using BIM has been in offering the other services, some coordination, and actually drawing some documents in 3D for people that don't have the technology yet. But we've not really had an owner that would pay us a premium for a BIM. Now, early on, our consultants, when we've got about 3 mechanical, electrical, plumbing consultants and 2 structural consultants that now do all their work in BIM. But early on, they did give us a premium fee for doing the job in BIM versus letting them work in a 2D environment. That has somewhat disappeared as they've gotten better and more comfortable with coordinating their work within our drawings and Also, they're getting better at, the hardest part was to go from 3D back to a 2D presentation, and that took quite a bit of a learning curve. But right now, we're not seeing a premium for it.
Hello there. My name's Derek Allen. I'm here in the room in London. My question: I'm an end user for buildings. Oh, excuse me, end user for buildings. And early in your presentation, you had a graph that explained how the costs could change. I'm sort of trying to get some quantitative value on that. Is it overall, does it make the project cheaper, I suppose, is what I'm asking. Whether or not you can qualify that for us.
Overall, I think it does. I don't think we're at the point of optimizing the building to where all the components have gotten to the point that they're as big as they need to be. But we have, and traditionally we've had good low change order rates for non-owner generated changes, but our change order rate is less than 1% for non-owner unforeseen conditions, coordination errors, and those kind of things. So I think from that standpoint, it is saving money. I don't think it's saving money on the initial bids at this point.
And now, similar question from two people, Mike Burney and Olufemi Akinola. And it's typically, who has primary ownership of the BIM model during design and through construction?
Well, and that's a question I see brought up at almost every meeting I go to. So far, in the work we've done, we've owned the model, and we've just, and that's purely because we've not had an owner or a contractor request the need to own the model. We do provide the model to contractors to do their, when they have the capability to do their construction level detailing, but it's done very carefully and with some fairly detailed hold harmless agreements and no guarantees on electronic transfers and those kind of things. But we've not gotten into a situation where we've done, say, a integrated project delivery process where the model moved from us to the contractor to the subcontractors completely at this point.
As a follow-on to that, there's also, if you do a fully coordinated 3D model, do you sell the model to the contractors? And that's from, I think it's Richard Crampton, if Tim would just...
We actually do. If the contractor at this point requests the model to take it, and we have an actual fee schedule for each sheet or each set of documents that we provide them that goes into the bid documents or into the contract documents. And it depends purely if they're looking for 2D conversion to 2D drawings to do coordination drawings, or if they're looking for 3D, and we basically have a flat rate schedule that goes into our front end documents, Division 1. So we let them know up front that it's available, and if they're able to use it, then use it to their advantage that they can get it.
Okay, thank you. Now from William O'Donnell. Does BIM allow for calculations of things like daylight factor modeling, natural ventilation appraisal, heat loss and heat gain calculations, or can the model be easily exported? Or can the model be exported easily to other software systems?
Well, again, it only takes about 10 seconds to export a GBXML file. Again, though the key is having the model complete before you do it, or know where the model is not complete, so you can go right to the point in your analytical software and fix those things before you start doing design iterations. but it's very easy to export both quantities, areas. If you've built cost into the objects, that's very easy to do, and very easy to do right now. That's not a future thing. It's quite easy to do, and then there are several third-party vendors that can take advantage of that data to run daylight models and energy models.
Okay, the last couple of questions. One from Derek Moulds regarding clash detection. Does the system automatically detect clashes between different elements, e.g. full height partitions and ductwork pipework?
It does, and in some cases it will give you clashes that you not normally would want to investigate in a 2D environment. For example, it will you run a clash detection, at least in our software, and it'll tell you that the drillings on the sink that the plumbing engineer picked are not the same size as the drillings for the fixture trim that's in the top of the cabinet, and things like that, things that would be easily adjusted in the field. You'll get a lot of clashes in some cases, and you just have to get used to knowing which ones are the ones that are serious and the ones that you can tend to ignore.
Thank you. And finally, who do you see BIM specialists working for? Direct for the client, main contractor, design team, or for the subcontractors? And that's from CIBSE CAD in London, Mark Robinson. And
Tim, I guess I'd ask, when you say BIM specialist, do you mean someone that's a BIM coordinator versus a designer or a contractor that's using BIM? Are you asking?
Yes, I guess the person who owns the model, I guess.
Ultimately, I think the owner is going to own the model. Maybe not the proprietary design processes or the construction processes built into it, but from the standpoint of owning and operating that facility, I see the owner as ultimately being the owner of that. And really, they own our 2D documents for that purpose now. They just don't own our copyrighted and trade-protected information.
Fine, thank you. It would be remiss of me, as we've got some listeners in Australia, not to hope you're not living in Brisbane, but also not to mention the cricket. Very sorry about that. That won't mean anything to you at all, Dennis, but believe me, it means an awful lot to us at this end. Normally at the end of a webinar, you're in receipt of a one-handed clap, i.e. silence. We have the privilege here of 25 people who've really enjoyed your presentation, so I'd ask them to show their appreciation on behalf of everybody wherever you are. Thank you.